Okay, well, today we're looking at basically stone, but the the repair and conservation of stone buildings really, when it gave rise to our whole approach to conservation in this country. So I will be sort of part way through this lecture, be looking at our approach to conservation and that in Europe, which differs quite slightly. So we'll make a start then, looking basically at the common types of stone. It depends where you are in the country as to what sort of local stone was used for both vernacular and smarter buildings. Obviously, for the higher status buildings, stone tended to be brought in from slightly greater distances. And of course, the coming of the canals in the 18th century and the railways from about the 1850s onwards really meant that one could get stone from much greater distances fairly easily and cheaply. And so this changed the whole sort of complex of what types of stone were used in your locality. Really, it's this sort of greater movement of stone started or was given a great sort of kick in the 17th century with the Great Fire of London and the rebuilding of the London churches using Portland and Purbeck stone, and the stone was brought round by sea and then by river. But in most instances, the stone that's used for vernacular buildings is quite local material. And so just briefly looking, one of the most common stones in our region are limestones, and it's sort of a very broad term is limestone. It covers a great range. And so over towards the western side of our areas, we have the oolitic limestones, and these are much finer sedimentary material. And the oolite bit relates to the shape of the remains of the little creatures that sort of create the limestone when it was deposited in the beds of sort of lakes and standing water. And so the oolitic limestones, the most popular one, of course, is Bath stone. And when you look at that under the microscope, you've got these sort of very fine little spheres of material. And it can be used for sort of fine dressings, but the upper levels of the stone was used as a freestone for just sort of general walling. And quite often you find, even sort of in the middle status buildings, that you have the sort of freestone walling that was then rendered over and probably painted with a lime wash with an ochre colour as a sort of cheaper way of making the building much higher status than it really was. In other areas, the creatures, if you like, that make up the limestone are much larger. And here you can see a typical shelly limestone from the Purbeck and Portland beds in Dorset. And you can see here virtually whole oyster shells. And this shelly limestone was very popular in the 17th century for the rebuilding of the great London churches and for many of the high status country houses that were constructed in the south of England in the 18th century. At the bottom of the stack, we've got Plunch, which is sort of the youngest of the limestones. Basically, it's a hard chalk. It's the lower beds of chalk. And this was used for both rubble walling and also for dressings in areas where chalk was abundant near the surface. The problem is that it's not very resilient as far as weathering is concerned once it's out on the surface. And usually it was covered with a fine lime render and lime washers in order for it to survive. And where it was used for dressed stonework, again, it would have had coats of lime wash on it. And quite often it survived from the medieval period right through until people started to intervene using cement mortars for pointing. And that led to sort of a rapid deterioration of the material. In other areas, we've got sedimentary materials that are basically sandstones, and they might have other impurities within them. And so in certain areas on the Hampshire, Sussex, Surrey border, we've got quite a lot of these very hard ironstones, iron-rich sandstones, and they're very difficult to dress. And so the common technique was galleting, which is chipping. The small chippings of the stone were used to press into the joints so that one didn't have great masses of lime mortar between the stone. So it's quite a difficult material to use, but again, readily available near the surface, and so was used in some areas. Other sandstones, you get a whole variety of colours depending on the amount of iron in the soil in the area and other materials leaching in. You also can get hybrids, which are neither a pure sandstone or a pure limestone. These are calcareous sandstones and again have different weathering properties. But the big problem with most of these stones, immediately you start repointing with cement mortars, you get rapid deterioration of the face of the stonework. In chalk areas, even if you're using a much better quality limestone for the dressings, flint quite often is used as a decorative material, and this can be napped, just one single face napped, or it can be napped and squared to give a very fine, high quality piece of flint walling. Again, with flints, galleting was very popular, and these were the fine bits of flint that were struck off the main nodules, were pushed into the joints so that one didn't see very much in the way of mortar at all. And so this is a typical galleted flint face to this Georgian building. In coastal areas, we tend to find that the flints where they've weathered out of the chalk cliffs have been rolled around with the sea, and one finishes up with basically big flint cobbles or flint pebbles. And there are sort of techniques in some areas of laying these horizontally, usually associated with brickwork in bands like this. And in areas in the southeast sort of corner of Hampshire into Sussex, East Sussex, you find this in the 19th century, this very peculiar technique of striking out the joints to look like brick jointing. Well, other stone material that's used in our area are the more fissile limestones that you get in the Purbeck area, and these are split fairly finely to provide roofing materials. So we get Purbeck and Portland stone being used for roofing, and also in other areas over towards the Sussex border, we find this Horsham stone being used. It splits fairly finely. It comes from close to the surface, so most of the quarries were very much sort of surface quarries rather than deep quarries. Out of our area, we get Cotswold stone slates, and again, these have got a particular character. And the reason I'm showing them is that, you know, by the time we get the railways being able to move materials around, we find that some of the higher status late Victorian and arts and crafts buildings in our area have Cotswold stone slates on their roof. Well, if you're wanting to look closely at the historic use of stone in your area, the best start is to look at the Historic England building stone atlases for your particular county. And these have a list of all the historic quarries that were in use. They have examples of the buildings so that you can recognize the stone in use as a building material. And they also indicate which quarries are still available, and there are very, very few of them still producing stone for matching your material. So quite a lot of stone repairs these days are done with material that's brought in from elsewhere, particularly from France, that are a close match rather than a good geological match for your buildings. And as I say, it's a very good source. And I just bring up here a page or two from the Oxfordshire Atlas, and it shows the various geological beds of material, and also pinpoints where the quarries were exploiting these materials, and then examples of the typical way the stone was used, either as a freestone with stone ashlar, quoins and window and door surrounds, etc. Well, as far as quarrying is concerned, historically, quarries were as close as possible to the building you were constructing. So this happens to be in the north of England, a medieval quarry at Fountains Abbey, and the quarry is literally alongside the building, as you can see here. That's the quarry face. And in fact, the quarry bed has been used for part of the ground plan of the abbey. And the coarser sort of upper courses of stone were used for the rubble core, and the lower beds were used for the more the finer sort of ashlar work. And so you get this very sort of close proximity between quarry and building construction. As we get into the 18th and 19th centuries, we get a slightly greater movement in materials, with quarries basically providing material for a broader location rather than just a building, but a town, a city, or a small region. And so here we've got a typical sandstone quarry, and the way the quarries worked, you worked the stratas, because each sort of strata, each bed of stone had its own qualities. The top beds tended to be used more for rubble work. The lower beds, much finer grain material, older in geological time, were used for the fine ashlar work. And so the quarries were worked within their stratas. Rarely do you get sort of the strata still being horizontal. In geological time, the upper crust of the earth being contorted by movement, etc. And so sometimes these stratas are running at anything like 45 degrees within the quarries. So not easy to sort of work some of these beds. You also get vertical breaks in the material, as well as horizontal stratification. You can get these vertical cleats running through the stratas of the stone, which makes life easier for extracting the sort of larger blocks. But the stone's always quarried on bed and then marked up for use on site on bed. More of that later. Well, in areas like Portland, a number of beds were worked at the same time in fairly deep quarries, and by the 18th century, you've got sort of fairly crude sort of cranes being used, and sort of 19th and 20th century, much more sophisticated winning of the various beds. And here you can see a typical Portland stone quarry. We've got all the different beds running here, and with rather nice names. It really takes a very good stonemason to begin to start and recognise which beds, or a good quarryman, which beds your particular stone of your building has come from. And so the lower beds tend to have these sort of bigger shells within them. Particularly the roach bed is an extremely sort of shelly bed, whereas the whip bed and the pericot and base beds are much finer materials. In Purbeck, in the Purbeck area, the quarries tend to be near the coast, and in fact the sea's just behind this horizon here. And the early quarries were actually into the face of the cliffs. And here you can see a typical Purbeck quarry. They've still got their 19th century crane here for shifting the stone blocks, with sort of the more recent behind. And you can see the stones won on bed in large blocks. And the way it was quarried was using a drill. To start with, this was a hand drill beaten in with a sledgehammer, and you drilled a hole, a series of holes along the bed where you wanted to split it, and then you used feathers and a wedge, and the feathers were slotted in the hole, and then the wedge was driven in along the line, and this split the stone from the bed. These days, this is all done sort of pneumatically, but in the past, it was done, as I say, by hand. And the vertical cuts, again today, are by a drill that you sort of work sideways into the face. In Europe, you have big sort of saws, particularly in Italy, cutting through the whole of the quarry face, and these were sort of a continuous metal hawser with industrial diamond tips within it, and you can slice great blocks out of the face of the quarry. But this is our traditional method of quarrying, and in some areas you'll see things like farm gate posts still have the evidence of the method that the extraction process left. So here's a typical coastal quarry, and this was producing stone for use in the 17th century for Wren's great rebuilding of the churches in London. And the stone was quarried horizontally into the face of the cliff. You didn't want the upper stone, that was mainly rubbish, so it was done via galleries into the face. And the blocks were brought out and just roughly shaped, because again, you didn't want to be transporting a load of rubbish to your building site if it was around in London. And so the blocks were sort of roughly made into rectangular blocks. The excess was packed off with a chisel and then loaded into flat bottom barges. And they sort of created docks into the cliff side here, and the flat bottom barges were floated in on high tide, They were loaded usually while the tides were passing, and then floated again off high tide and around the coast, sometimes offloaded onto larger ships in coastal ports. Sometimes the barges were man enough to do sort of a bit of coastal sailing. Other quarries where you don't get the very distinct bedding of the stone, the distinct stratification, are freestone quarries. And here you can drag the stone out, and it doesn't have a distinct bed within the stone. So as it suggests, you can freely use the stone without looking closely at the way that it's naturally bedded. And this tends to be used a lot for sort of the more rubble type of stone walling, and the stones can be trimmed up very easily with a cross pane hammer. In the Bath area, the stone was mainly mined in quite deep mines with horizontal rectangular adits going into the face of the hill. And the blocks were brought out as quite large blocks. Today they're cut with what looks like a giant chainsaw on wheels, and they slice the blocks into quite large chunks. But they still use the wedge and the feathers for splitting the blocks off the face of the tunnel, basically. And you'll see on these blocks, you've got this sort of line with a double arrow on. This marks the bedding plane, because sometimes with these finer grained stones, it's difficult to see what is the natural bedding. You can see the bedding plane here in these stones. And so they're marked up when they leave the quarry face, so that by the time they get to the mason's shop, they know which way to start and convert the stone. Well, the working of the stone these days is done mechanically. That's useful then for turning into the ashlar stone that you need to use. If you want paving, this is a block of York stone. It's been cut on a huge frame saw, and you can see you've got multiple blades sort of cutting down into the stone, the block of stone, to create your slabs. So after this primary sawing, you finish up with these large blocks of material with a bed height equivalent to the stone that you're wanting for your particular building. It's then secondary sawn to create the actual blocks for use in the building. And that dimensioning with a secondary saw is usually these days a circular saw with, again, industrial diamond tips. And these are all controlled by computer. So you can feed in the coordinates of the blocks that you want, set the machine running, and go and have a cup of coffee. And when you come back, you've got your block sawn. For some of the bigger jobs, they can program and use this equipment for 24 hours a day. It's running. So it's no longer is it sort of the honest craftsman with his hammer and chisel chipping away for hours to create these blocks. All the primary and secondary sawing is done mechanically, and it's only the handwork is only really for the finishing. The traditional way, was doing it like this, which was quite hard work. And the banker does the sort of final dressing of the stone. Banker, this is a bank. It's basically it's some sort of a very solid timber trestle with an absorbent material to take the jarring these days, for the wrist of the chap who's doing the dressing. So he's the banker who's doing the dressing ready for that shaped stone to go out on site. And for things like copings, again, you can do the sort of primary shape by mechanical saw, but then all the fine dressing is done on the banker's table. And things like brackets, console brackets, and fine carving. Again, well, the banker does the basic moldings and things like console brackets. When you get into the more decorative work, you have someone who is skilled as a carver. So you get this sort of splitting of skills within the mason's shop. And templates these days are done on sort of a plastic film. More historically in the 19th century and early 20th century, you used a zinc sheet to create your patterns. In the medieval period, you had a level floor with a lime mortar coating, and you actually inscribed your designs for your windows, etc., into that, and that was used then as your pattern for creating your great Gothic windows, etc. So here's sort of a traditional sort of templating for making a new piece of stone to insert into this arch. And so there's the template. It's been cut in the mason's shop to approximately the right shape. It's fixed into situ and then just finely dressed on site to get it matching up and in shape with the surrounding stonework. And here you can see the final dressing is done by a drag, which is basically rather like a carpenter's plane with multiple blades that are serrated. And you basically can rasp off and you can humour the higher stone into the sort of lower one to get a better sort of fit for your stonework. At the top of the pile, as far as skills concerned, is the carver, and he starts off using a punch and creates this. This is a corbel. They also did sort of gargoyles like this, and sometimes he works from a sketch. Sometimes, particularly in the medieval period, the guys worked from an image in their mind. And you know, naughtily it might be the abbess or the abbot, you know, they'd carve a grotesque face of for their sort of corbel table, etc. So gradually, you know, emerging from the rectangular block of stone, you begin to get the shape that the carver is punching out, and then he'll move to sort of finer chisels, a whole array of finer chisels to get the finished product. Okay, so that's sort of looking at the winning of the stone and the preparation of the stone for on site. What about the repair of our buildings? Well, the philosophy of approach to repairing buildings really reflects the sort of changes and attitudes in conservation and vice versa. And it's interesting that our sort of approaches to conservation really developed from particularly the latter part of the 19th century approaches to repairing stone buildings. So here we've got a good example. This is St Albans Cathedral. Before and after it was got at by this chap Edmund Becket, the first Baron Grimthorpe. He was an amateur architect and put most of the money in for the restoration of St Albans Cathedral. Prior to him, they had Scott as their, Giles Scott as their architect, and he had and his son had a fairly sort of lighter touch although they were still very much wedded to the sort of Gothic design. As far as Grimthorpe was concerned, later medieval stuff like Perpendicular, you know, was really a bastardization of the Gothic, and he went back to his idea of pure Gothic. And this horrified a lot of architects and educated people within society, and gave rise to, in 1877, gave rise to the Society for the Protection of Ancient Buildings. And their motto was anti-scrape. They didn't like this sort of return of buildings that had had years of development through the medieval period and later. They didn't like the clock being turned back to some architect's idea of what it might have looked like when it was originally created in the 13th or 14th centuries. So this was really the starting point of our modern sort of approach to conservation in general, building conservation in general. And we've tended to sort of go towards the, in this country, simply cutting out stone that's no longer structurally capable of doing its job, or capable of shedding water, particularly at sort of high levels like this, and replacing with new stonework. So you tend to get this sort of bit of a patchwork quilt sort of approach with historic stonework alongside new stonework, but eventually it will all mellow down. On the sort of purist end of the stonework conservation, we get the use of things like lime shelter coats and plastic repairs using, plastic really is the wrong word, but malleable materials in the form of lime and stone dust mixtures being used for gently repairing and getting the stonework to shed water again, and then covering the whole lot with a lime shelter coat to extend its life. So that's really the end of the spectrum that we are coming from in Britain for our conservation of stonework. It's useful to see how things have developed in Europe. You know, what are the European attitudes to stonework conservation and conservation or restoration or recreation in some areas as far as their heritage is concerned. So this was a few years ago. It looks as if I'm showing sort of photographs of my travels, but these were all study tours, quite legit. And it was interesting to see in Belgium about 40 years ago, their approach to conservation was basically they stripped the decaying stone and the decent stone off the facade of the building, all went into a skip, and new stonework was put back so that the building looked like it originally did when first constructed. And so when you visit the continent and in various areas of Europe, and you see these very pristine apparent medieval buildings, it's probably due to the whole facade of that building being replaced more recently. If by chance they came across any medieval material, it was removed and put into one of these architectural heritage parks to be studied by students. And you can see sort of the results of that in the center here. You've got the total replacement on about a 150-year cycle of the facades of these apparent medieval merchants' houses. Where the buildings are less precious, what tends to happen on the continent in order to keep the heritage aspect of the town, because many of these are UNESCO World Heritage Sites, they simply keep the facade and plug in a brand new building usually constructed with a concrete or steel frame in behind. Where they're dealing with a medieval building, albeit with a more recent replica stone facade, if they're extending it, again, there tends to be this sort of brutalist approach to aesthetics in various areas of the continent, where you make no bones about it being a modern extension. And, you know, I think you can make your own mind up whether that enhances the whole feeling of that conserved historic town. If we look in Germany, again, probably by necessity after the Second World War, the conservation of many of their medieval towns was fairly aggressive. In Nuremberg after World War II, after the great bombing of the area, some historic buildings did survive, but they made the conscious decision that in order to keep the feel of the historic fabric of their historic towns, they would respect the medieval layout of the town and the plot divisions. And so you get buildings slotted in which respect the original size of the building that was on site, and usually the height of the building as well. So they've recreated their townscape with a few historic surviving buildings dotted in amongst it. And the roofscape again has been sort of recreated. So it's both protecting surviving heritage and giving the surviving buildings a more compatible surround. In other areas, like Dresden, which was originally on the in eastern Germany, the clock really stopped after the war, and things like the cathedral here in the centre of Dresden, the great church, was badly bombed, and only parts of it survived, and the rest was left as a rubble heap. This is in the town centre. And you can see this was a photograph in the 1980s with sheep grazing around the remains of this great cathedral. After the fall of the Iron Curtain, the whole of the centre of Dresden was reconstructed, and the decision was taken to go through the rubble heap of the collapsed cathedral, sort out all the decent stonework, and it went on racks here according to where it came from the building. And then it's been put back with new stonework around it. So you've got this rather sort of patchwork effect of new and old material. So they've conserved quite a lot in their sort of, you know, is this salvaging or is it sort of recreating the heritage, you know, of their stone building? The buildings around the market square, again, they've taken working from the photographs pre-war and any architecture drawings, etc., that survived. They've recreated the townscape around the cathedral, around the market square. And so this looks again like a series of 18th and 19th century commercial buildings with their fine facades, etc. But in fact, the whole of that block is one huge hotel. The exterior still looks like it did prior to the war. And occasionally they found fragments that had been salvaged from the original building. So the whole of this facade has one piece of original stone, which you can see there. Again, in Russia, after the war, there was a lot of destruction, and the communists decided, they made a conscious decision to restore the great palaces for the benefit of the people. rather than anyone living there. So they were sort of as museum pieces. And they did a fantastic job sort of recreating from photographs, etc. So when you visit these great Russian palaces and you marvel at the beautiful 18th and 19th century architecture, a lot of it, in fact, is recreation after the Second World War. And probably the peak of that sort of recreation can be seen here at the Cathedral of Christ the Saviour, originally built in the 19th century, but Stalin had it blown up in 1931. It was the highest building, the most prominent thing in Moscow on the skyline. And so as a reminder of the old order, had to be destroyed. And in fact, they constructed a swimming pool for the people on the site. In 1997, it's after the fall of the Communist Party, it was decided for the 850th anniversary of the founding of Moscow to reconstruct the cathedral faithfully in all its details. And this was a $200 million US dollar recreation of the cathedral with 6.5 tons of gilding on the dome, etc. The main core of the building is a modern concrete and steel core, but the whole of the exterior is beautiful stonework. And so this gave the opportunity for training craftsmen again in working with stone. And internally, frescoes have been recreated, and so fresco artists were trained up, and they are now being used, like the stonemasons, for the conservation of the surviving historic buildings within Russia. So although it's a bit of a sort of a Disneyland recreation, the spin-off has been a great deal of rebuilding of traditional skills and knowledge in order to conserve the rest of their heritage. Also interestingly here, up to a few years ago was one of those horrible grey Stalinist office blocks. This is now being recreated as the scene that it was. This is within the Kremlin area, with its beautiful sort of 18th century buildings. And this, in fact, is the hoarding around the scaffold that's painted up with a depiction of the building that will be there once that scaffold comes down. So it's recreating the setting of some of the heritage buildings in the Kremlin area. And the big discussion now is what to do with the old Communist Party HQ, which is a rather fine piece of post-war architecture. And, you know, the dilemma is, do you keep the best of the Stalinist architecture, or do you do like Stalin and wipe out the past? So, you know, that's still an open question. During the communist period, historic buildings that got in the way were moved to open air museums. And here at Kazai, you've got the open air museum where in fact it was timber buildings that were moved, but it shows the sort of beginnings of their ideas on conservation. And when I visited the huge cathedral there, the log-built cathedral was being conserved very carefully by the new breed of conservators in Russia. Log by log, they were being taken out of the building, little splinters sort of pieced back in to keep the majority of the historic material. So it showed, you know, the new attitudes. Again, in an area that was communist during the 20th century here, Bulgaria, the heritage was recognized in the second half of the 20th century as being something that could be a cash cow as far as tourism is concerned. And so they started to sort of excavate and then restore this historic area. The Roman town, they rebuilt a section of the Roman town walls and the Roman tower. The medieval city, which was ruined after the sort of Turkish invasion, parts of that were being reconstructed with new towers, etc. And then in 1981, they reconstructed the cathedral as an eye catcher on this prominent position at the top of the hill. So it's part sort of conservation of the historic fabric, it's part sort of recreation, and tourism was the sort of driver for it. Well, you know, height of the communist period, reconstructing a cathedral. Internally, the frescoes were done by a sort of modern fresco artist, and it represents the heroic achievements of the Bulgarian kingdom of the past. So, you know, rather than sort of religious themes. Portugal, we get basically blatant facadism, particularly in their UNESCO World Heritage towns and cities. And you can see it in action here, the stone facades being propped up. And the following year when I visited, a new building had been plugged into the back, but no attempt to sort of confuse what was historic and what was new. Here we've got the whole of the exterior shell, which is stone and these beautiful tiles, being very carefully saved in situ, and behind it you've got a cast concrete frame when you go inside the building, and cast concrete floors. Greece, completely different attitude, more aligned to our attitude of stonework conservation. And here at the Parthenon, they take great pains to conserve the last fragment of historic stonework. So where it was necessary to piece in stone for structural purposes, they've carefully profiled this new stone so that they are not removing any of the historic material or discarding the historic material. So a very expensive, even on sort of plain rectangular blocks. So a very expensive exercise. And basically they're reversing some of the repairs that were done during the 19th century, where sort of all sorts of metalwork was used to conserve the building. And in some areas they're doing partial restoration in order to put back some of the historic features, but only enough to give you the feel of what the original classical architecture looked like. They have a big job on in some areas where metalwork was used in the 19th century to sort of hold together the stonework. As this is rusting, it's blowing the face off. And we have this problem here with many of our 19th century pieces of restoration work where metal cramps have been used. Their attitude towards original stonework, where it's out within the elements, is not to conserve in situ, but to take it off, put it in a museum and put facsimiles back. So when you visit the Parthenon today, these caryatids are in fact manufactured, cast stone replicas of the originals that are in the Parthenon Museum. And here we've got, a whole area of historic stonework within a museum preserved. And most of the visitors found this very entertaining. The ancient Greeks were also blighted by mobile phones. Okay, well, moving on to decay problems. The biggest problem, as I alluded to, for historic buildings on my previous lecture, is water. Water pollution, and then sort of vegetation getting in and damaging the structure. Pollution, particularly hydrocarbons, cause a sulfate skin, particularly on the surface of limestone, and this sort of creates great blisters which eventually sort of blow off, and you get cavities within the being formed within the stonework. And you know, it's very easy to sort of blame the Victorians with their smoky chimneys, etc. But in fact, in more recent times, we've pumped out the same amount of hydrocarbon pollution into the atmosphere over a 10-year period than the whole of the sort of industrial revolution through to the beginning of the 20th century. So 10 years worth of pollution, you know, equates to 150 years of earlier pollution. This is doing great damage to our stonework. Again, mismanagement of water disposal on particularly buildings that are constructed in stone is a great problem. And then, you know, following up with bird droppings and then seeds and plants and trees growing, it very quickly can destroy stonework. So maintenance and management, particularly of water on stone structures, is very important. And if water gets within the structure, you can finish up with this sort of situation with the leaching out, particularly where lime mortar was originally used for in the construction of the building. Mortars that have not yet carbonated within the depth of the building, you get a lot of water flowing in, that will wash out to the surface, and then you'll get carbonation occurring, and you get these sort of stalactite type deposits. So it's important to keep water out of even the top of ruins. Ground salts, again, can be a blight, usually caused by high water table or high water levels or flooding. And you get this problem at what I call the tidal zone, between areas that are continuously damp, areas that are dry. You've got these fluctuations, seasonal fluctuations, where this stonework is wetting and drying all the time. And this is where the salts that were in solution have come out onto the surface and are blowing the stonework apart. And again, you can see that situation here being aggravated by dense renders. So what can we do about the management of salts? Well, the first thing is to make sure that one reduces the moisture content at the bottom of the walls with adequate drainage. And we need to make sure that the drainage actually works and doesn't become a moat in winter. And then what do we do about the residual salts? Well, with decorative stonework like this, one can use a poulticing system. This is a clay poulticing system which pulls out the salts into the clays, and by using this over a period, you can pull out, you can desalinate the stonework beneath, but it's a very slow system. Another cause of decay is wind scouring. And here you can see you've got these sort of deep cuts in the stonework, and this is following the bedding planes in the stone. So we've got very basically soft beds naturally occurring within the stone, and the wind is the way that this building is being constructed. It caused vortexes in some areas of wind around the building, which will scour away the softer lenses of material in the stone. So again, it's a difficult one because it's down to the original plan and form of the building, and also the selection of the stone. Things like drip mouldings are there for a purpose, to throw water off the stonework beneath. And so copings to sort of parapets and buttresses like this, hood mouldings to windows and doorways, designed to throw water off. And if you keep these in good repair, you shouldn't have a problem with the stonework beneath. But you can see here where we've got a decayed coping, water's been allowed to flow down the face of the building, and eventually this is where you'll get sort of maximum decay down the stonework. So we need to repair those hood mouldings and copings, etc. What is not a good idea is to use sort of lime and stone dust type repairs where you're going to get maximum weathering. And so here, the proper way to have done this repair would have been to actually cut and piece in new pieces of stone to shed the water effectively. This repair was probably half the cost of piecing in a new piece of stone in that situation, but it's only lasted 10 years. The original piece of stone had lasted 150 years. So look at all the effort that's gone into this, you know, and the embodied carbon in the original material. You know, why not go back? It's much greener and saves the rest of the building if you go back, spend that little bit more to put back, you know, a decent new piece of stone to do that job of water shedding. Again, repointing. Well, you know, one questions whether this stonework actually did need repointing. The joints are very fine. It's facing the sea, as you can see here, and it's been rather ham-fistedly repointed, question mark, with a cement mortar. And this has locked in the salts into the surface, particularly the chlorides from the sea air, into the stone, and the stone's retreated. The cement's still as good as its guarantee. It's been there for at least 20 years. But it's rapidly caused the deterioration, caused the rapid deterioration of that area of stonework. And again here, you can see this is magnesium limestone in the north of England. And the worst thing you can do with that is encapsulate it in a strong cement mortar. It really does accelerate the pockets of decay. You know, this looks like a dentist's worst nightmare. Yeah, so we need to think about repointing and the mortars that are being used. And sometimes we can design mortars to do a specific job. Here we've got in Hampshire, this is a late Saxon church here with its tower and its south porticus. And it was constructed in flint with the local green sand stone dressings. And this green sand had survived beautifully from the late Saxon period until about the 1860s, when the scraping lot decided to remove the nice lime render that was over this flint work, and the lime wash, the layers of lime wash on the green sand coins. They stripped it all back to show the glory of the original constructional material, and really to emphasize then the flints, they raked out the joints, raked out the lime mortar from between the joints, and they put back basically a one-to-one mix of Portland cement and boiler slag to give you a nice black pointing. And of course, what this has done is concentrate all the problems of salts into this very vulnerable greenstone dressings. So the problem was, how could we conserve this material? Because it's late Saxon, you don't want to start replacing it. You can see it was in quite a state. And so that was treated with lime mortars and lime dressing and for its repairs. And basically they couldn't afford to rake out the whole of the work here, and so we've created sort of a sacrificial strip about 1 metre wide around the green sand dressings, etc., and at the base of the building. And this has been repointed with a lime mortar with crushed chalk in it, coarsely crushed chalk, to act as porous particulates. So any moisture and salts are attracted away from the green sand dressings into this material. We did this work about 40 years ago, and the green sand survived beautifully, except for this one block, which was really beyond it. And more recently, that's been replaced with a new green sand block. But the other 99.9% of the green sand has survived. I mentioned the importance of knowing the correct bedding of the stone. If you get it wrong, this is an example of face bedding of a block, and basically it delaminates when out in the atmosphere. And so on this 19th century building, they weren't very careful about bedding the blocks correctly. You can see it's been face bedded, the natural stratas on its end, and it started to decay, and it's peeling back like peeling back the pages of a book. And again, the cement, the very strong cement pointing in this sort of very pronounced pointing hasn't helped. It's locking all the salts in, and the surface of the building's decaying. Then, of course, a little bit of skill and aesthetics comes into it. You know, I think the owners here thought they got their money's worth out of the guy repointing it, because you can see quite clearly his repointing. But this has destroyed the whole character of, this is on the Isle of Wight, on the multiplicity of the different types of stone used in this vernacular building. Anything that was to hand on the surface has been used, but it's been made a real mess of by the repointing. And again, on the island, the clunch, the hard chalk clunch has been used here for this vernacular, 17th century vernacular building, survived beautifully for 300 years, and then somebody repoints with a cement mortar, and the chalk clunch blocks are decaying rapidly. Sometimes we've got a problem with the original design of the building. Here we've got stone with basically a coping, a stone coping, up a very steep slope of the roof here. And at the end of this coping, you need a block of stone known as a kneeler. And the idea of the kneeler is to sort of overcome the thrust of the stonework coming down this ski slope. And if the kneeler isn't big enough, you tend to get sort of a rotational movement, and you can see that's resulted in a crack back through the structure. So in this particular case, what we don't need to do is replace this kneeler. We accept that it's undersized, but what we do is drill vertically through these copings into the core of the structure, and we put anchors in every third block, so that you've stopped this movement of these copings down the slope of the roof, and that will you know, conserve the end of the building. As you can see, this is a barn, and in fact originally it was thatched, and inevitably, you know, in the 20th century you've got the crinkly tin on, but at least it's preserved this medieval building. Other problems is impact damage, and this is in the middle of Oxford. You can see, or is it Cambridge? Whoops. Yes, well, probably some of you viewing this will recognise the building if it is Oxford. But here you can see impact damage from large vehicles going round a corner here that wasn't designed for juggernauts delivering. And so, you know, what's the answer here? Well, you know, you can just continue replacing this piece of stonework on the corner, but what we really need to do is protect it. And so the ideal thing is to put a damn great RSJ bollard, you know, well, carefully designed to fit the aesthetics of the townscape in the corner here, so that you tear the side of the wagon out rather than the side of the building. You know, that's real conservation. Okay, well, the problem with many of our stone structures is that they have got a stone facing, a nice ashlar stone facing, but the core of them is rubble. And over the centuries, you've finished up with voids within that rubble core. And so you need to grout it. Or if you're replacing face stonework, you can never get all the voids behind fully filled with mortar. And so what's been used for centuries by masons, stonemasons, is a grouting technique where basically you pour in a fine liquid grout of lime and a fine material into those voids to fill them. And this can now be used on a large scale for sort of conservation of ailing medieval structures. Here in the New Forest of Hampshire, we've got the East Boulder Church, and basically the west end of the church was peeling away from the rest of the building. And it's an aisle building, and so the last two bays of the arcade, the nave arcade, the arches were beginning to sort of spread as the whole building started to sort of try and move westwards. So what one needed to do was tie the whole lot back together. And this was done using a modern method of anchors and grout, the Syntec method, where they've drilled sort of 8-meter sort of long drills right through the structure and put sort of anchoring rods in, and those rods are perforated, they're hollow and perforated. Around those rods you put sort of a fabric sock, and then you pump grout into that hollow rod, and out through this fabric, coarsely woven fabric sock, you get fingers of grout moving out and filling the voids within the structure. And so you can graft together the two leaves, you know, the outside and inside leaf of the wall with the core, and then consolidate it sort of diagonally, and then drill long drills right the way through into the arcade to anchor the whole lot back. And so this basically was done 35 years ago and has saved, you know, collapse of the west end of that church. And so these modern techniques are being used more and more these days. They're tying lighthouses together using this technique, other historic buildings, and even using it where you're getting cuttings, railway cuttings and road cuttings through cliffs. You can tie back cliff faces using this sort of system. Okay, very quickly now we'll move on to the way that the stonework is put together, the bonding of the stonework. And you get various styles. Here you can see you've got finely jointed work in this Cambridge College here, where the joints are virtually invisible. It's very sort of tightly, very fine stonework. On other of the Cambridge College buildings, you get this coarse rubble work, this random, both coursed and uncoursed rubble work, giving a different character to the face of the building. Also, if you sort of examine the wall forensically, you can see how it's been constructed. And here you've used rubble, and about every 2'6" lift of work, you've leveled it, and then you've gone up again and you've leveled it, and so on. Well, you need to study the way that the wall's being put together, because if you're repairing it, you need to do it in a similar way. Otherwise, it will, it won't look right. You need to be able to match in, and you need to see the constructional techniques. And again, here you can see you've got these large stone quoins on the corner, and the rubble work has been lined up in lifts according to the quoins. So you've got this sort of leveling technique through the stonework. And again here, the blocks have been leveled over 2 courses. Again, this is out on the Isle of Wight. With dry stone walling, again, it's key to looking at the local vernacular technique of the way the walls are being put together. And in this particular case, you have these long bonding stones tying the 2 sides of the wall together. In other areas where we have, this in fact is in Wales, and it's slate blocks, you've got irregular sized blocks. It's been the way that they've sort of coursed these and sort of snacked them together is very characteristic of that particular walling technique. Well, here you've got an example of someone not thinking. This section of a wall was demolished by a car going through it, and I think it was a bricklayer rather than a stonemason was brought along, and he's faced with a heap of stone, and so he puts it back with lime mortar in between and then puts the coping back. But as you can see, the character of that section of rebuilt wall is completely different to the piece alongside it. He just hasn't studied this to see the way that it was put together with these large blocks and coursing in between, etc. So it's absolutely critical to study the wall. And again, the wall can give you evidence of change. Here, 2 different techniques of construction with a butt joint in between, and you've got quoins here showing that this original building, the corner was here with its quoins. This has been added to it, and a different hand, different period, different technique of stone walling. Here we've got evidence for change. A building here has gone alongside this gable, and this is where the joint was between the roof of the previous building, the earlier building, and this one. And again, also, this has been re-roofed, and the pitch of the roof's been changed, and you can see sort of a new construction here, new stonework in the sort of changes. So you need to read the building and see how it's being constructed. I'll try and speed up a little here because I realise where time is going. Yes, cleaning a building. Well, in the sort of 1960s, 70s, shot blasting was all the rage to clean up your buildings. And you went to Yellow Pages, got man with space suit, huge compressor and very sharp sand, and he did a nice job cleaning your building. He'd take off a quarter or half an inch off the surface and round off all the corners. A really sort of bad way of cleaning. When you've got paint on the surface, what do? Well, you can bring in this chap with his blowtorch, and it was absolutely amazing he didn't set fire to the roof structure while he was doing this operation of scraping and peeling off. So removal by heat of paint off stonework, you've got a tremendous fire risk possibility. What about water washing? Yes, well, here you can see this chap's got a high pressure water washer, and he's getting rid of all the grime off the surface. But notice it's opening up all the joints, and also it's finding the softer lenses in the stone. So in fact, this guy's doing more damage trying to clean the building than leaving it with the pollution on it. So not a very good technique. Far better is using hand spray and an ordinary bristle brush, just gently softening up the pollutants and then brushing off. Well, the game changer back in the 1970s was the cleaning and conservation of the front of Wells Cathedral. There was great debate as to what was to be done. You had marvelous medieval statuary on the face. One sort of side of the conservation lobby suggested removing all these statues, sticking them in a museum like you do in Greece, and putting back artificial stone facsimiles. Another group of scientists suggested, well, we're just perfecting this marvelous new material called silane, and we can impregnate the surface of the stone, we can coat the pores, etc., and stop it deteriorating. You know, how long have you been working on this? Oh, for the last 2 or 3 years. How long have you had it on field trials? Oh, at least a year, you know. Well, do you tackle something that's been there for 700 years with an unproven system of consolidation? So at the end of the day, a chap called Professor Baker was brought in, and he suggested using lime to conserve the limestone. You know, not rocket science really. And so to get rid of the rubbish off the surface, what he suggested was slaking lime on the surface of these statues. You sort of wrap them up in a coat of Hessian, you put the quicklime on the surface, you spray water on, you get this exothermic reaction. The heat frees up the oils and other rubbish that's binding the pollutants on the surface. And after a few days, you can peel off that lime that's on the surface. And here's sort of a half before and after. You can see how successful it is. And also, some of the lime moves back into the pores of the limestone and helps to start and consolidate it. And then that was followed up by something like 35, 40 coats of clear lime water on the surface, which again helped to consolidate that stonework. And it survived beautifully. And very interestingly, while they were doing that conservation work, they found that some of the small details, in some pockets there was coloured paintwork, suggesting that quite a lot of that facade must have been quite gaudy with coloured pigments on the statues, etc. And also, where there'd been damage historically, it had been very carefully, they'd given it sort of splints of bronze and copper wire around, sort of holding it together. So that careful conservation technique, you know, had been done in probably the 18th century and 19th century. And so they were continuing to conserve in that gentle manner. So here you can see the work being cleaned down. Sorry, I went back one there. The alternative was consolidating with silanes. Works beautifully in the laboratory where your stone's absolutely dry. It's highly carcinogenic, so you have to be careful how you put this material on. And it's supposed to coat only the pores of the stone, the internal surfaces, leaving the pores open for the stonework to breathe. The stone has to be absolutely dry. Well, in this country, when do you get, you know, more than a few days of drying sun and winds, you know, on all surfaces of our historic buildings? So works fine in the laboratory, but not in the field.